as Steve Squire says, we have a great rover but a lousy dune buggy. So it got to just about the floor of the crater, but they didn't want to actually drive it into the sand, partially because the sand probably wasn't really that interesting. They're more interested in the rocks. They found a very strange rock called Wapme. I don't know where that name comes, but this it's all cracked up, which might indicate it went through cycles of wetting and drying. And this might actually have fallen from a higher layer on the crater, or it might be impact ejecta. And then it spent a lot of time at this cliff called Burns Cliff, and look at these beautiful layers in the cliff, in Burns Cliff. At the time, the rover was tilted about 20 degrees when it took this image, but they were very confident it could handle that tilt without tipping over. This is another picture of Burns Cliff. The Endurance Crater, just like Eagle Crater, the rocks are rich in salts and jarosite, and because we're sampling a much greater depth, which represents deposits laid down over a much greater period of time, this means we don't know exactly how long the time period was, but the water must have persisted here for a very long time. We're probably talking many thousands of years, maybe even millions of years. We don't even know exactly when these were laid down. We're probably talking like 3.5 to 4 billion years ago. This is questions for future missions to address. So here, this is interesting too. It's like Mars early on was still going to be a fairly cold planet, especially because the young sun was less energetic than the sun today. So how could Mars have liquid water on the surface? Well, the possibility is that salts dissolved in water could have lowered the freezing point of water, allowing water to exist in a liquid state even at the cold temperatures. But another interesting thing that by going deep down into the crater is that the composition of the rocks did change with depth, meaning that the environment must have changed over time. Now, after it left Endurance, it went down, got close to the bottom, and then climbed back out of the crater, back out onto the plains, and it investigated its heat shield just outside the crater. Actually, this is a little black mark from where it hit on the surface. Now, unfortunately, they didn't create a picture in 3D, but on the other side of the heat shield, they found an iron meteorite. In fact, I think you can, yeah, right here. See this rock right here? That turned out to be an iron meteorite. And it was interesting, they spent quite a bit of time analyzing the heat shield because the engineers wanted to see what kind of damage it experienced during its passage through the Martian atmosphere to help them design future rovers and landers. Okay, then it started rolling south toward this larger crater that I mentioned called Victoria, and it took these beautiful pictures of these sand dunes. This one was called the Rub al-Khali Panorama, named after the giant empty quarter, the Rub al-Khali Desert of Saudi Arabia. And this is another one of these small impact craters, about 50 feet wide, a little smaller than Eagle Crater, called Natural East. Now, here we're now about 1.4 miles south of Endurance. And by the way, a lot of these drives, there were drives where this was doing hundreds of yards every day. Really amazing long drives. Just seeing more of the sand dunes here. And then it got stuck. It got stuck in this sand dune that they called Purgatory Dune for over a month, and there was concern that they weren't going to be able to get it out. But using a twin rover at JPL, they eventually figured out how to spin the wheels just right to get it unstuck so it could continue its journey. Here we see more of these beautiful layered rocks, and you can kind of see there's like wavy patterns. This is evidence, like you can see it over here, of waves in an ancient Martian lake or sea or maybe river. Yep, here we see more evidence of wave actions near a small crater called Erebus Crater. Okay, and this is another trench where the rover got stuck for a few sols, but by this point they really knew what they were doing, so it was only stuck for a few days.
How deep is that hole?
Let's see, did I say here? Probably just a few inches deep. Probably we're talking 5 or 6 inches deep. Okay, then on December 2006, it made it to the rim of Victoria Crater. Now this is a half a mile across, 240 feet deep. This is by far the largest, deepest crater that has ever been explored on Mars. It's interesting, the blueberries were small around the rim but big near the bottom, so that indicates to geologists that the source of water might have been underground in this region. Okay, so they didn't release very many 3D pictures of Victoria, unfortunately, but it spent 2 years exploring Victoria Crater, and now it's heading south toward this much larger crater called Endeavour, but it's going to take months to get there. As they did it, they had done some new software. You can see here where they drew a circle. You can also see these older tracks as it was going around the crater. These tracks might have been from a couple years earlier, but they intentionally did some squiggling with the rover wheels to test out this new software. They noticed too that as they went deeper down into Victoria, the minerals required more alkaline and neutral conditions deeper down, whereas the higher rocks were for more acidic water in the distant past. So the question is, deeper down, the water that was there was more hospitable for at least our kind of life. So the question is, could life have started long ago when these deposits were laid down what would become the bottom of this crater, and then eventually the water became more acidic over time, probably from sulfur ejected by Martian volcanoes? And the question is, if life got started early on Mars, as the water became more acidic over time, could life have adapted to these new conditions? We don't know. That's future scientists and missions may be able to answer that question. Okay, so this was taken in February of this year after in one day driving 364 feet. And I like this quote from Jim. He said, "I think the rovers are like wild animals released into their native habitat, thriving in the environment they were built for and truly fulfilling their birthright." Remember, these rovers, the conditions on Mars, it's cold, no water, thin atmosphere. These rovers were designed for that environment. Maybe we shouldn't be surprised they've lasted so long. This is a Cook Islands pan released on March 12th of this year. Opportunity has now traveled a little over 10 miles. That's really pretty amazing. It's currently heading south toward a 13.6 mile wide crater. Remember, Victoria was half a mile across. So if this thing can get to the rim, we're going to have a very dramatic view. Both rovers are still going strong, other than the fact that Spirit is currently stuck. They're still able to recharge their batteries, generate electricity to run the instruments, the radio, the computers, and the heaters. And as I mentioned earlier, the Martian dust devils and wind gusts have really helped clean off the solar panels. So these rovers have both scientifically and technologically have vastly exceeded the expectations of their builders. And even if, like, both of them were to die tomorrow, they would have to be considered a spectacular success. I think one of the great successes of the space age.
Do the rovers have any more rat left in them, or is that all?
It's mostly, they're pretty grinded up. Yeah, they're probably not going to. I think with opportunity they can still do a few more, but they're really nearing the end of the rat's lifetime, like, because it just got grounded down, so it gets to the point they just can't do anything.